Mastering error handling in Python involves using try-except blocks to catch exceptions and ensure smooth program execution. Custom exceptions allow developers to create specific error types, enhancing code clarity and debugging. By designing tailored exceptions, you can provide more informative error messages, making your code more robust and easier to maintain. Exceptions are crucial for defensive programming, allowing developers to anticipate, catch, and handle errors effectively. This transforms fragile code into resilient, robust applications. Understanding exceptions is key to writing reliable Python programs, ensuring smooth execution even when unexpected issues arise. Exceptions are runtime events disrupting program execution, unlike syntax errors caught during parsing. Common examples include zero division, error for division by zero, type error for invalid operations, file not found error for missing files, value error for inappropriate argument values, and key error for missing dictionary keys. Handling exceptions prevents abrupt program crashes, ensuring continuous operation. It allows for graceful recovery by offering fallback options and retry mechanisms, maintaining stability. Additionally, it enhances user experience by providing clear error messages and improves debugging with detailed logging. In basic exception handling, the try block contains code that might fail. The except block catches specific errors, like zero division error or file not found error. The else block runs if no exceptions occur, while the finally block executes regardless, ensuring cleanup tasks like closing files are completed. A traceback is crucial for debugging, detailing the execution path to an exception. It includes the exception type, like zero division error, an error message explaining the issue, and a stack trace showing the line-by-line execution history. Reading it from bottom to top helps identify where the error originated. Custom exceptions transform error handling by aligning with your application's business logic. They provide clarity and specificity, offering domain-specific messages like invalid email format error instead of generic errors. This approach enhances code maintainability and allows for fine-grained control, enabling precise exception catching and tailored responses to different error scenarios. Custom exceptions enhance clarity by providing specific error messages like invalid email format error instead of generic ones. They allow fine-grained control, distinguishing between errors like database connection error and database query error. This improves code maintainability by centralizing error definitions, making them reusable and easier to update across modules. To define a basic custom exception, inherit from the exception class. Override _init to accept parameters like age, storing error context. Implement _rows for clear error messages. For instance, invalid age error is raised when age is out of bounds, providing specific feedback. Use specific except clauses to handle these exceptions effectively in your code base.